Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In today's video, we're going to see how we can utilize the ChatGPT to carry out ANOVA test. So this is video number 11 in our video series regarding the ethical use of AI research. We have different types of ANOVA. We have the one factor or one-way ANOVA. Then we have the two-way ANOVA, which is normally referred to as two-factor. And the two-way ANOVA is further classified into two. We have the one with replication and we have the one without replication. So let me briefly explain that. So we normally use ANOVA when we have independent groups that are more than two. So let's assume this is an example that we try to see the influence of the fertilizer type of the crop yield. So let's say we have a local manure, then we have the factory fertilizer and the mix, that is the mixture of the local manure and the fertilizer. So and these are the individual yields that each of these one produce. So we try this maybe in a different field, like 11 of them. So we cultivated this in 12 different fields using local manure, then 12 different fields using factory fertilizer, then 12 different fields using the mix. So you see, had it been these are two, we'll go for a t-test or z-test depending on the sample size and also the standard deviation of the population if it is known. So but since these are more than two groups, so we are now going with what for the ANOVA. And this is called a one-way or a single factor because the yield is affected by the fertilizer type, whether organic manure, whether factory fertilizers, or the mixture of the two. So that means the yield is only affected by what? By the type of the fertilizer. And in this case, you only have one null hypothesis. That is, you will now say the type of the fertilizer has no effect on the yield. So that means the average yield of the manure will be the same with the average yield of the factory fertilizer and will be the same with the average yield when the two are mixed together. That will now be your alternative null hypothesis. Then your alternative hypothesis will now be that what the means are not the same. Then okay, let us now further segregate this influence. Instead of using the 12 field, let's say 6 of the field, we use a different variety of seed. Then the remaining others 6 will also use a different variety of seed, as seen here in this particular example, whereby we have the local manure, we have the factory fertilizer and the mix. But in this situation, the first 6 field we use seed type 1. Then the second 6 field we now use the seed type 2. So here we have two factors that influence the yield. One is the manure type, the fertilizer type, sorry, and then the type of the seed that is being used to give that particular yield. So here we're going to have three null hypotheses. One is this, that the yield will not be influenced by what? By the first factor, which is the fertilizer type. That means the average of each will remain the same. The fertilizer type will not have any effect. Then our second hypothesis will now be the type of the seeds will also have no effect on the what? On the output. Like because I use seed type 1 or seed type 2, if I use local manure, the seed will now have no effect on the yield. So this is the category number 2. So the null hypothesis 3 will now be the interaction between these two, like the influence of the fertilizer type and the influence of the what? Of the seed type will now combine and what? And influence what? The yield. Like for instance, I can now say, okay, let's assume the local manure, under the local manure, the yield of seed 1 and the yield of seed 2 has no difference. So here there will not going to be a kind of interaction between the two factors because all these things they are the same without any problem. So maybe Under this local manure, if the yield of seed 1 is higher than the what? Than the yield of seed 2, so the two have interacted. They have a combined effect on the yield. So here I can now reject the null hypothesis. So in the null hypothesis, I can now say that there is no interaction when it comes to influence on yield across the three group, either because of the seed type or the fertilizer being used. Okay, now let us do the analysis and see what it will give us. Then we'll now go and do the distance. For the first one, we're going to use a single factor. So I will just select everything, including the headings. So here I will click the labels because I have selected everything. So I will now have to choose the where I want the output to be. So let's go paste it here. So I can now say okay. So I will now quickly go and do the same for the second situation. So here I will go back to that data, then I will come to data analysis. So here is a what? Here is a two-factor with replication because I have more than one values. So I can now say okay. So I have to choose everything, including the labels. So I will choose them and I will now say what? Okay. So I have to choose the output range. So let me just choose something like this. So I can now say okay. Okay. So it has covered this thing. Okay, let me just clear this. It has covered the first this thing with this. So let me just clear it and clear this and redo it again. So maybe I will select it somewhere here. So I will go to the data. Yeah, I will go to the data analysis two-factor. I will say okay. I have already selected everything, only that the output range I will change maybe to this place. So I will say okay, then okay. So now it is there. So this is the one factor without a replication because we have the organic, the fertilizer type and the seed type. But in this situation, we only have one reading for each. So it is without replication. So I will also carry out the data analysis for that. So here I will go to two-factor without replication. So I will select this. Then I will also, let me change the output range. Let me just place it here. I can now say okay. So it has covered something. So let me change the output range. So let me just put it here. Okay. So now we are done. So okay, this is for the first scenario, which is the, uh, the one way. So here we assume that the fertilizer type has no effect on the yield. So we can use the F value. So if this calculated F is less than the F critical obtained from the table, we accept the null. So if this F calculated is greater than the F from the table, we reject the null hypothesis and accept the alternative. Or we can use the p value. So this is 0.00 up to 6 places, then before this value. So that means this is less than 0.05, which is our margin of error. So in this particular case, we're going to reject the null hypothesis. So we'll now say that the fertilizer type has influence on the yield. So that means the mean are not the same. So let us now come to uh, the uh, the the other one, whereby we have the three null hypothesis. That is the two-way with replication. The first one, we will say that the fertilizer has no effect. So here we have the P calculated to be 41.14. Then we have the P critical to be what? 4.17 distance. So because this f value is greater than this, so we're going to reject the null hypothesis. So we say that the fertilizer type has what effect. Then we come to the second null hypothesis, whereby we say that the seed type has no effect on the yield. So here the F value is 42.28 and the F critical is 3.3. So the calculator is greater than the critical. So we're going to also reject the null hypothesis. So we're now going to say that the seed has effect on the what? On the yield. Then when it comes to the interaction, we want to see whether there is a combined effect of the seed and what and the fertilizer type on the what on the yield. So here we have F value to be 3.42 and here we have the F critical to be 3.31. So in this particular case, the F calculated is greater than the F critical. So also reject the null hypothesis. We will now say there is a kind of an interaction effect. The two factors interacted and they influence the what this, or you can equally use the p value. In all of this situation, the p value is less than 0.05. So you reject the null hypothesis in all of this. So now we have seen how we can use the Excel to do that. So let's assume we don't know what type of the ANOVA test that we should use. So let's see where ChatGPT can help us solve that issue. Let me just copy the first one. So I will just come to the ChatGPT and I will now ask it to, let's say, perform ANOVA, let's say ANOVA test and conclude. So I will now paste. So I will ask it to run. So let me just copy for the second one. That is the one with the replication. So let me just copy this. So I will say copy. Then I will use a different browser so that maybe let's say also here I didn't specify to the ChatGPT whether the other one is a single factor or a two-way ANOVA. So I will also say the same here, like let's say perform ANOVA test. Let's say and conclude. So here we didn't specify anything to the ChatGPT. So let's see whether it will understand whether it is this thing. So you see in this particular first scenario, it has already understood that it was a kind of one-way ANOVA. So it has calculated the F as 17.89. Then it has the p value as 5.46 to the power of 10 raised to the power of minus 6. And it has concluded that we reject the null hypothesis. So you see here it has also uh, save you from the trouble of either to reject or to accept. So let's just cross check and see whether these values are somehow the same. So you see the F is 17.89, then 5 point this to the power of minus 6. So what the ChatGPT did was actually correct. So let's check the second one that we haven't specified anything to it. So let's see. Okay, I didn't paste the, okay, I didn't copy the table. So let me just copy the table. Okay, let me just copy this. And I will come back to this. So let me just, so I thought I had pasted the table. So I will just send this. So let's see whether you can understand it's a two-way. Actually, I wanted to save time and what I intend to do does not yield result. So we have to wait for the. So you see, actually, it has not uh, specifically understands whether it is a two-way or one-way because it solves the problem using a one-way ANOVA. So let me just ask the ChatGPT to perform two factor. Let's say two factor. And see whether it will now do it properly. But in the first one, we just paste the value without specifying whether it should be two factor or not. So let's see now whether it will. So it is now calculating. So it has given you the null hypothesis already. So you see three. One is that the effect of the fertilizer, which you will assume no effect as your null hypothesis. Then the effect of the seed, which you will assume no effect. Then interaction, you assume no interaction. So let's see. Still analyzing. So let's wait for it. So it has done that. So it has calculated the p-value for each, and it has made a conclusion. With regard to the first one, the effect of the fertilizer is set okay. With the effect of the seed, it says that it has effect because the calculated p-value is less than this. Then with regard to the fertilizer effect, it also says that it has effect because the calculated value is less than 0.05. With regard to the interaction, it says there is a kind of interaction between this because 0.0456 is less than that. So let's check whether these values are also correct. For the interaction, we have 0.0456. Then let's check this and see the p value. Okay, 0.0456. Then the first one we have 4.41 to the power of minus 7. Okay, so the same thing, 4.41 to the power of minus 7. Then for the next one, 1.86 to the power of minus 9. Okay, so actually it is correct. So you see the ChatGPT can actually help you to carry out all these things. So all what you just need to do is to know the basic, then it will help you to carry out that and it will conclude for you. Assalamu alaikum.